So welcome everyone. Today we're here to present the new project, which is called an AI-based framework for harmonizing the climate policies and projects with the Sustainable Development Goals. I'm Francesco Fusonerini. I'm Associate Professor in Energy Systems for Sustainable Development, and I'm the Director of the KTH Climate Action Center. And I'm today joined by my colleague, Ricardo.
Hello, everybody. Thank you for joining today. My name is Ricardo Vinuesa. I'm an associate professor also at KTH in the Department of Engineering Mechanics. I'm also vice director of the KTH digitalization platform, and I'm also involved in the KTH Climate Action Center together with Francesco.
Perfect. And let's start a bit with the background of why this proposal. And this proposal tries to understand and unveil some of the dynamics of interactions among Sustainable Development Goals. So since the SDGs were introduced in 2015, an exciting field of research has started that tries to understand how these goals can be achieved synergetically. So how the 169 targets that are within those goals can be used to direct, understand, improve research policy and projects. And to date, a lot of studies have emerged, for instance, using qualitative expert-driven methods, using methods based on literature, methods based on stakeholder participation. However, these studies to date, and some of those are here on the right, have some key limitations. Well, first of all, there are some biases associated with data gathering and expertise of the experts that do this analysis. And also there is a limited possibility of analyzing scientific literature and evidence to understand these interlinkages. So again, remember that we're looking at 169 targets, so a lot of information needs to be reviewed. So yeah, basically what we claim here is that a new approach is needed to mainstream using the SDGs to guide policymaking and project development. So the hypothesis, the hypothesis in this project is that AI methods can be used to revolutionize the study of SDG interlinkages. And what we propose is that we want to use the field of natural language processing, or NLP, which is a subfield of AI, to automatically identify synergies and trade-offs among the Sustainable Development Goals. And in this project, we aim to do so first by testing it with understanding how projects within climate action, so mitigation adaptation, can be harmonized with the SDGs. But more broadly, we want to create a tool that is available for policymakers and project developers to do so even in a broader scale. So now I leave the word to Ricardo to explain a bit more about the methods and the structure of the project.
Thank you very much, Francesco. The idea, and this is a project that we got funded for from Digital Futures, so that's the topic that we're discussing today, is to basically extend all the framework that Francesco has discussed, which is usually based on expert elicitation, so basically experts with many different areas of expertise who discuss, interact, and try to really come up with a consensus-based assessment to really try to extend that and use artificial intelligence, in particular NLP, to be able to, first of all, remove the bias that is introduced by expert assessment, and second of all, to really extend massively the amount of sources, the amount of data that can be analyzed and gathered to have a quite complete assessment of all of this. So our project is divided into three main blocks, the three work packages that you can see on the screen. In the first work package, what we do is that we will establish a classification. So we will do unsupervised learning, and we will get later a bit in more detail into the methods, but essentially we will have a number of references. We're talking about thousands of articles and research projects that are automatically classified by their connection with each of the 17 Sustainable Development Goals. That classification, as I mentioned, is unsupervised, which means that we are not giving any labels, but it's the algorithm itself which is able to really identify the connections. In the second work package, step number 2, we will use that information which is basically a massive database of articles and projects connected with the SDGs, to be able to establish connections among those SDGs. So we want to really have a matrix like this one, but something a bit more dynamically in terms of a database, of a dynamic database, where we can really see how one SDG is impacting all the others in a positive or a negative manner. And that again is done in an unsupervised way that requires quite some understanding of the meaning that the article has and of the implications on different areas. And for that, we will be using, one of these very popular tools now that have been developed in NLP, which is transformers. Transformers are attention-based neural networks, which are able to process massive amounts of texts, massive amounts of data. They're attention-based in the sense that there is embedding of being able to establish connection between the words in a particular sentence, and through, well, being able to get some sort of understanding of the meaning of the text, we will try to establish those positive and negative connections among SDGs. So once again, this is an extension of the previous work that Francesco has referred to, which is basically relying on expert elicitation, but a bit in a more objective way, because it's driven by the massive amounts of articles that we can find, and on the assessment through the transformer architecture. So in the second step, we will come up with these metrics that you can see here, where we have positive and negative synergies across SDGs. Now, of course, this can establish a bit of a conflicting scenario, right? Because if we want to improve one particular SDG, we may actually be impacting negatively many others. That's why we have the third work package that you can see here on the right, in which we will use optimization algorithms to be able to come up with optimal policy decisions in terms, for example, of investment. We have a particular amount of funding that we want to use to really develop a particular SDG. And of course, the two of us being involved in the Climate Action Center, SDG 13 on climate action is one of our priorities. So we can really try to establish basically the non-trivial connections, because so far the studies relying on expert-based elicitation have been able to identify quite obvious connections, but now with AI we can reveal those non-obvious connections, and using, for example, gradient descent, Bayesian optimization, but even more advanced techniques like reinforcement learning for dynamically changing environments, we can kind of have the possibility to develop optimal policy decisions. So once again, first connect articles and projects with SDGs, then positive and negative effects, and then finally the policy decisions that are optimal given this scenario. Now, going a bit more into the details, we are going to really go into all these subtasks within the three work packages. And this is actually work done in collaboration with several actors. One is the Polytechnic University of Valencia, where the group of José Alberto Conejero and Sergio Ollas have really been instrumental in developing the material for work package 1. We have actually presented our results in several congresses now with quite some nice reception. And then we have a great support also by Professor Javier García Martínez, who is the president of the International Union of Pure and Applied Chemistry, the IUPAC, who is really an active researcher also in the context of the SDGs. So this is part of a quite large international effort where we are actually engaging a number of collaborators and stakeholders. We can also provide some overview of some of the methods employed for the first connections. And we can see here the first approach based on latent directly allocation. So LDA, latent directly allocation, is a generative probabilistic model very widely used in NLP, which really allows us to establish the themes. So connecting the various articles and references with SDGs. And this is work that we have already published in the work by Talal and others, where we basically connected references and curricula of computer science universities, a number of universities, and we associated them with topics and subsets of the data pertaining to those curricula. So we have really assessed how LDA can be effectively used to make such a classification. And in the next slide, we're actually going to see another alternative to perform this. This is the non-negative matrix factorization, which is based more on linear algebra. This is basically a matrix decomposition approach, which is actually, as you can see here for the example of SDG2, quite effective in performing such a supervised learning methodology. So you can see also this is work by Dillion and others who can really establish the possibility of using the non-negative matrix factorization approach for a supervised learning in very large databases. So this is a little bit of the perspective, and if we go now to the final slide, we can really show a little bit the significance with our strategic partners. I mentioned some of them, including Javier Garcia Martinez, but we have a number of other collaborators and very impactful partners in this work. And maybe Francesco, you can give some final words also to the effect of our strategic partnerships in the project. Thank you very much for your attention, and we are happy to take questions and to really discuss further if you're interested. Thank you so much.
Thank you. And as Ricardo was saying, this is a very interesting project that we look forward to take forward and develop.